at this question, it looks extremely complicated because of this part. You know what you do when you see something like that?
Give it another variable?
Give it another variable. Whoa, whoa, whoa. That's too complicated. You know what? Let me let you be just a as a function of x, and let me worry about it later. Like this. Okay? Then this is, you can think of it as arc cosine of a as a function of x, and dy over dx then will be 1 over, or negative 1 over square root of 1 minus a as a function of x squared, chained by the derivative of a. Okay, that's the first step. So this involves doing quotient rule with this. Shouldn't be too bad. Differentiate the top and you get a minus a sine of x times by the bottom. Okay, minus b plus a cosine x. Differentiate the bottom and you get a minus b sine of x, right? Alright, let's expand this. You get a minus a square sine of x minus a b sine of x cosine of x, and you get a minus b, wait, it's plus b squared sine of x, and then you get also a plus ab sine x and cosine x. Okay, so that cancels out. That's good news.
What's that?
You can see? Okay, these two are the same, so I canceled that out.
A something, oh, AB something cosine.
AB sine x cosine x.
Oh.
Okay, so I'm going to put the positive first. You get b squared sine of x minus a squared sine of x all over a plus b cosine of x. Okay, so that's it. It's minus 1 over square root of 1 minus, what was a? B plus a cosine of x, a plus b cosine of x, all of that squared. Okay, no, yes. Okay, so that multiplied by this. Okay, this looks pretty ugly still, right? So there's got to be maybe some things we can do to make this a bit nicer. So do you see that this thing at the bottom? This. Okay, let me multiply the tops together and I get this. Yeah, this does take some more extra effort. The bottom, if I actually add, right, I get this. Square root of, okay, I get this. I get a plus b cosine of x squared minus b plus a cosine of x squared, and all the entire bottom is a plus b cosine of x squared. So I square the top and bottom separately, and I'm subtracting it with a 1. Okay, so let me write this at the bottom like this. So a plus b cosine of x all squared, b, oh, that's already there, that's already done. Okay, that's right there. So you see, do you see that the bottom, right? The bottom here, right? It's, if you square root this, you're gonna just get a plus b cosine of x. Okay, let me multiply this negative in, and this becomes positive now. You get, so a squared sine of x minus b squared sine of x. Okay, so is that, yeah. So I could actually factor out the sine of x, right? I could factor out the sine of x. Okay, and then the bottom we get this. A plus b cosine of x squared. B plus a cosine of x squared all over a plus b cosine of x multiplied by a plus b cosine of x squared. So you see that that'll get reduced with that one, right? Okay, so on the top now I have I guess I can factor it. Sine x, a minus b, a plus b, and at the bottom we have this, so a plus b. I'm just going to put it at the front, and we have a square root of what we have inside. And I could factor it as a difference of squares, but
No point, really.
well, let's try it. A plus b cosine of x, right? A plus b plus a cosine of x. A plus b cosine of x minus b minus a cosine of x. So see if this helps at all. Okay. So at the bottom, okay, what do we get at the bottom here? We have a plus b, and a plus b. So you can actually factor out a plus b. Do you see that?
But it's not going to cancel.
A plus b, you can factor out cosine of, right? Cosine. So look, a plus b, you can see that you can factor out a cosine of x, and you get a plus b, right? True?
Yeah.
And here you have a minus b, and you can factor out a cosine of x, and you get another a minus b. And so I was hoping that maybe it'll cancel out with a plus b or a minus b, but I don't think it does. So let's just stop. So you know what? We could have just stopped here, okay? When I cancel that out, but I just tried that for fun, and it does look a little bit nice and clean with the pattern.
Okay, there's